Hello everyone, welcome to my channel Maths with Sneha. So in previous video we have discussed how to decide the order of double integration. Now in this video we will see some examples of double integration when the limits of integrations are already given. Okay, so now here see the first example I have written on the board. Here double integration from 0 to 1, again from 0 to 1, and the function here is given as 1 upon 1 plus x square into 1 plus y square. In previous video we have discussed that when limits of both the integrations are constant, then we are free to choose any order. Means either we can take dx into dy order or we can take dy into dx order, since the limits of both the integrations are constant. So now here you can either take dx into dy or dy into dx. So let me take a dx into dy order. The order dx into dy means what? Ki first we will integrate with respect to x. So while integrating with respect to x, we'll keep the terms of y as a constant, and then after putting the limits, whatever the stuff we'll get, we will integrate that stuff with respect to y. Okay, so now let's proceed. So here I is equal to what? Double integration from 0 to 1, 0 to 1, 1 upon 1 plus x square into 1 plus y square, and the order of integration is what? Dx into dy. The meaning dx into dy means what? Ki first we will integrate this function with respect to x. So while integrating this function with respect to x, the terms of y, that is 1 upon 1 plus y square term, we will treat as a constant. And since this constant is multiplied to the function, so while doing the integration, that constant will remain as it is. We will just integrate the function in terms of x with respect to x. Now this is equal to what then? Integration from 0 to 1, and now since with respect to x the terms of y will be constant, so I will write this 1 upon 1 plus y square as it is, since it is a constant. So while doing integration these terms will be as it is, and the integration of what? From 0 to 1, 1 upon 1 plus x square, and this term we have to integrate with respect to x, and whatever the stuff we'll get after putting the limits, that stuff we have to integrate with respect to y. So now here we have to integrate this term with respect to x, and the term is what? 1 upon 1 plus x square. So let us recall one formula. Formula is what? Integration of 1 upon 1 plus x square dx, and the formula is, it is tan inverse of x. Tan inverse of what? X. So this is what the important formula. Kya? Ki integration of 1 upon 1 plus x square dx is equal to what? Tan inverse of x plus c, since the limits of integrations are not given. If the limits of integrations are given, then we will not add that c. Okay. So using this formula, this integration, I am keeping 1 upon 1 plus y square as it is, and the integration of 1 upon 1 plus x square is what? Tan inverse of x. And the limit are from 0 to 1 and then dy. Now since we know that while putting the limits, first we will put the upper limit, then minus we will put the lower limit in the same function. So it will be what then? Integration from 0 to 1, I will keep 1 upon 1 plus y square as it is. Now here replace x by upper limit. So it will be what? Tan inverse of 1 minus tan inverse of 0 and into dy. Now this is equal to what then? 0 to 1. 1 upon 1 plus y square as it is. What is tan inverse of 1? Tan inverse of 1 is what? Pi by 4. This is what tan inverse of 1 is what? Pi by 4 minus what is tan inverse of 0 is 0. Now here we can observe that inside the integration pi by 4 is a constant which is multiplied. So that constant we can take outside of the integration. So I will continue over here. This is what then I will be equal to integration from 0 to 1. Now since pi by 4 is a constant which is multiplied, so that constant I will take outside of the integration. It will be pi by 4 into integration from 0 to 1, I is equal to, and 1 upon 1 plus y square dy. Again here the same formula will get applicable, only the variables are changed. Here we have the variable x, now the variable is y. So the formula is again same, that is tan inverse of y, and the limit will be from 0 to 1. So it will be what then? Pi by 4, again same, tan inverse of 1 minus tan inverse of 0. Now as we have discussed earlier, it will be what? Pi by 4 into what is tan inverse of 1 here again? Pi by 4 minus 0. So the answer is what? Pi square by 16. Okay, so this way how we have to solve the integration when the limits of integrations are given. So let us see the next example given on the board. Example number 2, integration from 0 to 2, integration from 0 to y, and the function is x into y. Now again let us see ki what will be the order of this integration. Now observe the limits of inner integration. अभी inner integration के limit देखो. Inner integration के limit में कौन से variable present है, y है, कौन सा variable absent है वहाँ पे, x absent है, right? So here first we will integrate with respect to x. See, inner integration के limit में y है, कांस्टेंट भी है, कांस्टेंट को छोड़ दो, कौन सा वेरिएबल नहीं है वहां पे वो देखो, y है x नहीं है, राइट? सो देन हियर वी विल इंटीग्रेट विद रिस्पेक्ट टू x फर्स्ट, देन बचा कौन, y, सो देन वी विल इंटीग्रेट विद रिस्पेक्ट टू y. नाउ लेट अस सी हाउ टू सॉल्व दिस एग्जांपल. सो I will be equal to what, double integration from 0 to 2, 0 to y, x into y, and the order is what, dx into dy. Dx into dy order means what, ki first we will integrate with respect to x, and then after putting the limits, whatever stuff we'll get, we'll integrate that stuff with respect to y. Now again, while integrating with respect to x, the terms of y, if present inside the integration, that terms of y we will consider as a constant. So now here, while integrating x into y with respect to x, we will treat y as a constant. Okay. Now this will be equal to what then, integration from 0 to 2. Now since y is a constant, so that constant we can take outside of the integration. So it will be what, y, then remaining is only integration from 0 to y of x, and that x we have to integrate with respect to x, and then whatever the stuff we'll get, that we will integrate with respect to y. Okay, now let's proceed. 0 to 2. Now integration of x with respect to x. Now recall the formula. Which formula? Integration of x raised to n dx. What is the formula? It is x raised to n plus 1 upon n plus 1 plus c plus c. This is what the important formula of integration. What? Integration of x raised to n dx is what? X raised to n plus 1 upon n plus 1 plus c when the limits of integrations are not given. But here already we have the limits with integration, so we will not add a c here, right? So now here use the same formula here. Here the power of x is what? 1. So the value of n will be equal to 1 in that formula. So just put n is equal to 1 in that formula. So it will be what then? X square divided by 2. And put the limit from 0 to y, and then integrate with respect to y. So this is equal to what then? Integration from 0 to 2. Replace x by upper limit first, then minus in the same function replace x by the lower limit. So it will be what then? Y. When you replace x by upper limit, it will be what? Y square divided by 2 minus when you replace x by 0, it will be what? 0. Now simplify this, it will be what then? 0 to 2 multiply by y inside. So हमें क्या मिलेगा फिर यहाँ पे? Y cube divided by 2 and then dy. Now here we have to integrate this function with respect to y. See, आपका example correct जा रहा है या नहीं, ये आप कैसे समझोगे? At the end जब भी आपका single integration रहेगा, तो single integration के अंदर एक ही variable में सब कुछ आना चाहिए, function भी and variable भी, मतलब एक ही इसमें आना चाहिए पूरा. अगर x and y अगर अंदर mix हो रहे हैं तो समझो कि कहीं पे तो कुछ गलती हो गई है, ठीक है? Now यहाँ पे भी अभी क्या करना है कि same formula जाएगा. See, इनसाइड द इंटीग्रेशन जब भी आप इंटीग्रेशन करोगे, जो भी कॉन्स्टेंट्स मल्टीप्लाइड रहेंगे, ट्राई टू टेक दैट कॉन्स्टेंट्स आउटसाइड ऑफ द इंटीग्रेशन. नाउ इनसाइड द इंटीग्रेशन 1/2 इज देयर, व्हिच इज अ कांस्टेंट, सो दैट वी कैन टेक आउटसाइड ऑफ द इंटीग्रेशन. सो देन इट विल बी व्हाट देन? आई विल कंटिन्यू ओवर हियर. So I will be equal to what? So this 1/2 I can take outside of the integration. 1/2 remaining is what? Integration from 0 to 2 y cube dy. Now try to apply the same formula over here. Just the variable is changed. Okay. So now here the value of n is what? 3. n का value कितना है यहाँ पे? 3. Put n is equal to 3 in the same formula. So using the same formula, the answer will be what then? Y raised to 3 plus 1, that is y raised to 4 divided by 4. जब भी हम इंटीग्रेट करते हैं तो हम वहां पे क्या करते हैं कि पावर को 1 से इंक्रीज करेंगे. जो भी पावर रहेगा while doing the integration, add 1 in that and write down the same power in the denominator. Okay. And now let apply the limit from 0 to 2. So it will be what then? 1/2. Replace y by 2. It will be what? 2 raised to 4. What is 2 raised to 4? It is 16. So 16 by 4 minus replace y by 0. It will be 0. Now just simplify this. So this will be what? 16 by 8. You can more simplify this by cancelling the common factor, or you can keep this as it is. Okay, this way how we have to solve the double integration when limits of integrations are given. Okay, So let us see the another example given on the board. So here I have taken integration from 0 to 1 and integration from x square to x of function y. So now here we have to integrate y function. But now again, see, as in previous example, we have discussed that how to decide the order of integration. So here also we have to think with respect to which variable we are going to integrate first. See, जब भी हमें ये order decide करनी है तो हमें क्या करना है कि we have to see the limits of inner integration. Inner integration के limit में जो भी variable absent रहेगा उसके respect में हम पहले integrate करेंगे. So here we can observe that in limits of inner integration x is present and y is absent. So now here we will integrate with respect to y first, then bacha kon x. So then after this we will integrate with respect to x. So here order of the integration is what? Dy into dx, means first we will integrate with respect to y and then we will integrate with respect to x. So let us solve this example. So I will be equal to what? Integration from 0 to 1 x square to x of y and then dy dx. So since the order is dy into dx, that means first we will integrate y with respect to y. So now here we have to integrate y with respect to y, and in previous example we have seen the formulas. So integration of y with respect to y, as I told you that while doing the integration we are increasing the power by 1. So here the power of y is what? 1. So integration जब हम लेंगे तो हम क्या करेंगे? 1 में 1 add करेंगे, right? So it will be what then? Integration from 0 to 1. Integration of y with respect to y will be y square divided by 2. Same power we have to write in the denominator and then put limit from where to where? X square to x, and then we'll integrate with respect to x. Now here we have to replace y by first upper limit, then minus replace y by lower limit. So it will be what then? Here here when you replace y by upper limit, it will be what then? X square divided by 2 minus when you replace y by lower limit, it will be x square its square. So it will be x raised to 4 divided by 2 and the integration with respect to x. Now take term by term integration. Okay. So now here again while doing the integration we will increase power by one term and the same power we will write in the denominator. We will stick to the one formula only. So now here we have x square. So the integration of x square using that same formula will be x cube divided by 3. Already here we have 2. So 3 into 2 will be 6. So the integration, first integration will be what then? X cube divided by 6 minus here again the power is 4. Now the power will get increased by 1. So it will be what? X raised to 5. And 5 will get multiplied in the denominator. So already here we have a 2. So 5 into 2 will be 10. And the limit will be from where to where? 0 to 1. Now just replace x by upper and lower limit. It will be what then? I will be equal to, now first replace x by upper limit. So it will be what? 1 cube. What is 1 cube? It is 1. So 1 by 6 minus, here it will be 1 by 10. And when you replace x by lower limit, that is 0, it will be a 0. Now simplify this further. It will be what? By doing the cross multiplication, it will be 10 minus 6 divided by 60. What is 10 minus 6? That is 4. 4 divided by 60. You can more simplify this by cancelling the common factor. So it will be what then? We can divide both terms by 2. It will be 2 divided by 30. And again we will divide by 2, so it will be 1 by 15. So I is equal to this 1 by 15. Okay. Now in this video we have discussed that how to solve the examples of double integration when limits of integrations are given. We will end our video here. So if you find this video helpful to you, then please like it, subscribe my channel and share the same videos with your friends. Thank you.